Hello everyone, my name is Jasmine and I'm from Toronto, Canada. Today I will be presenting my research on intervention of age-related memory impairment by integrative musical stimuli. So elders aged 65 and above are vulnerable to conditions like mild cognitive impairment or MCI, dementia, and even Alzheimer's disease or AD for short, which could lead to impairments in memory, cognition, and much more. The global cost of dementia-related healthcare exceeds $1.3 trillion annually. This image shows the morphological changes involved in brain atrophy. But however, right now there is no effective cure for MCI or AD that can affect the long-term disease progression. So in this image, line 1 represents normal memory decline and normal aging. Line 2 shows early and rapid memory decline in AD patients. Line 3 shows current therapies, and line 4 represents future therapies that could decrease the rate of long-term memory decline, potentially achieved by combining drug-based treatment with cognitive behavioral therapy. So therefore, there's research on physical and music therapy to supplement long-term AD treatment. Music therapy has many benefits, including being non-invasive, low-cost, highly accessible, and emotionally beneficial. 40 Hz frequency stimulation is also found to decrease A beta plaques, tau tangles, and ultramicroglia, which are all hallmarks of AD, and I used 40 Hz as a potential positive control in my experiment. The problem with music therapy now is that we do not know what factors mostly determine its effectiveness. So, in my study, I aim to answer the question of how do music genre and preference influence the effects of music on memory impairment. And I hypothesized that music can improve memory and its effectiveness is influenced by both music genre and preference level. So I used the pre and post test method with behavioral test and the EEG to test the changes in memory with and without music therapy for 22 participants aged 9 to 84. I observed the impact of 6 music genres on memory over 22-day-long cycles, and day 0 is the baseline score later being compared to day 22. I quantified memory retrieval using the 10-word test or TWT for verbal episodic memory, in which participants recall a list of 10 words belonging to 5 semantic categories, and the digit span or DS test for verbal working memory, in which participants recall 6 double digits in the presented and inverse order, and both memories are impaired in AD. Each music therapy session is 20 minutes. Next, I employed the random forest machine learning algorithm to predict long-term memory outcomes, which are day 22 TWT and DS scores, based on short-term data from the first 7 days. That way, we can quickly determine whether a certain music therapy would be helpful in the long term, which saves time from trial and error processes. And to explore the underlying neurocorrelates of music therapy, I used the EEG to measure changes in cortical electrical activity before and after music. I used a headset from Emotive and it has 14 channels and uses saline solution. So for my results, I'll be first talking about the TWT and DS analysis based on genre and preference, then machine learning, and finally the EEG. So starting with some genre analysis, I subtracted the baseline score from all TWT and DS scores and averaged individual results for each genre. And points above the x-axis indicates an improvement from the baseline. I also compared day 0 and day 22 scores to find the percentage change and compared it with the negative control. So we can see here that classical and folk music effectively improves TWT scores and classical music improves the TDS scores. The rest are not significant or NS. Now, what about preference? Preference level 1 is the participant's most preferred music, and level 6 is the least preferred music. So I did the same calculation relative to the baseline, as well as the percentage changes compared with the negative control. And interestingly, preference level 1 or their favorite music resulted in the highest and statistically significant improvements in the TWT and DS, which suggests that preference is a strong influencer of the effectiveness of music therapy. Next, I also calculated the mean squared error, or MSE, of the machine learning model predictions based on the predicted versus real difference, which gives us a percent error within 10% for both the TWT and DS. And again, we can potentially decrease the time it takes to evaluate whether or not a certain music is going to be effective in the long term. All right, so let's talk about some EEG data. The top left image shows what the raw data looks like. And in this example, when a participant listened to most preferred classical music, I saw a decrease in amplitude after music therapy, and frontal cortex channels exhibited the biggest changes in amplitude. Then I also looked at changes in theta, alpha, low and high beta, and gamma frequency band powers in the frontal cortex. These frequencies can be indicative of the participant's mental state. And for channel F7 in the left brain, there's a decreasing trend in theta power. For channel F4 in the right brain, there's an increasing trend in theta power. And for channel O2 in the occipital cortex, there was not an obvious change in frequency. So, for the effect of music genre and preference, results suggested that most preferred music can most effectively improve one's memory. In terms of genre, classical and folk music seem to be the most beneficial. In addition, EEG channels in the frontal cortex showed the most impacts in amplitude and frequency, and the occipital cortex showed the least impacts, which suggests that music may play a larger role in frontal cortex behaviors. The differences may be connected to the varying roles of the brain regions, as the frontal cortex is largely involved in cognitive functions. So, therefore, music therapy of different genres and preferences could lead to differential regional stimulation and cognitive effort. And of course, there are also some methodological variables and limitations in this experiment. So, firstly, I did not use white noise for my negative control because studies suggested that white noise could potentially help improve cognitive performance. So, to ensure actual control, participants didn't listen to anything in a negative control trial. Also, lyrics were excluded to avoid possible interference with cognitive tasks. And as well, for a few participants, memory methods like associating an image with each word may help improve their TWT performance. And to help me identify motion artifacts, I also did an EEG precision experiment and collected data while the participant firstly didn't move or think, then while they thought about moving but didn't actually move, and finally when they moved their facial muscles. So I found that the EEG captures both pure brain signals and muscle movement, but signals without movement are relatively smaller. So, in conclusion, preference is an important factor in music therapy. Classical music improves the TWT and DS, folk music improves the TWT, and the machine learning model can effectively predict long-term memory outcomes using short-term data, and music potentially has a modulatory effect on frontal cortical activities. So I would like to thank my parents, participants, teachers, and senior care centers for the time and support throughout the project. Here are some of my major references, and thanks for listening.